Okay, now we want to talk about what do pendulums do. And so our picture this time is that we're going to have a string, and the string is going to have a certain length L, and then we're going to put some kind of a weight on the end of it. And so the weight could have a mass M, the same way that we put a weight on the end of a spring. And then we're going to pull it out a certain distance, but normally we refer to the angle at which we pull it out. So with the mass, we pull it straight down and then let it go. But this time with the pendulum, we're going to pull it off to the side and we're going to let it go, and it's going to swing back and forth. And so what we want to be able to do is to calculate what is the frequency at which that pendulum is going to swing back and forth. And so notice that it's very similar to the frequency of the spring, in that this time the frequency of a pendulum is going to be 1 over 2 pi. So it's the same, it begins the same way as the other one does. It also has a square root like the other one does. And this time it's going to be g. Now, do you remember what g was? So g is basically gravity. It's the acceleration due to gravity. Gravity is what's going to be pulling this pendulum down. So the force of gravity acting on this mass is going to try to pull it down, but the problem is it's attached to the string. So instead of going straight down like this, it's going to be in a curving arc, and it's going to go back and forth. And then it's also going to depend on the length of the string. So notice that it has a constant on the top, just like the one for the spring had a constant on the top, and then it has some kind of a variable on the bottom. In the case of the spring, it was the mass was on the bottom, but in the case of the pendulum, it's going to be the length of the string. So I could ask you some conceptual questions about it. So see if you can answer this conceptual question. You have a pendulum that has a certain mass M attached to a certain string of length L. And so you're going to pull it out and you're going to let it go, and it's going to oscillate back and forth with a certain frequency. Now what I'm going to do is repeat the experiment, but this time I'm going to have a larger mass. What do you think is going to happen? What's going to happen to the frequency of this pendulum if I attach a larger mass to the string? Now I encourage you to try this. So you can get some string and tie some paper clips to it or something so that you have some mass on there, and change the mass and see what happens. Keep the length the same. Now technically the length ought to go to the center of mass, so the length ought to go to the middle of this thing. It's not going to make that much of a difference because this is very small in comparison to this length up here, but in lab I'll have you do that. Measure it to the center of the mass. So what do you think is going to happen? Well, you might be tempted to think that the frequency is going to change because it changed with the spring. Well, the only reason why it did that was the formula had M in it. So the frequency depended on the mass that you put on the spring. But notice in this formula, there's no M. So the M is not there. So that means it's not going to affect the frequency. So that technically speaking, you could have a ping pong ball and a piano. And assuming no air resistance, if you pull the ping pong ball out and let it go, and you pull the piano out and you let it go, it's not going to make any difference in the frequency. They would both swing back and forth with the same frequency as long as they had the same length. Now, in fact, there is wind resistance, and so that is going to affect it. But assuming you're doing it like in a vacuum chamber where there was no air resistance, then the two of them would swing at the same rate. All right, now try this one though. What about if you went to a different planet? Okay, so let's say you go to the moon and you've got this mass. It's going to be the same L, but what's going to be different though is you're on a different planet. What's going to happen? All right, so do you know anything about the moon? The moon is smaller than the Earth. So what do you think that says about the gravity on the moon? It's going to be smaller. We'll learn about that later. But the gravity on the moon is smaller than gravity on the Earth. As a matter of fact, it's like about 20%. So that the G value on the moon is going to be about 1/5 of the G value on Earth. So on the moon, this G is going to be smaller. So what does that tell you about the frequency? It means that the pendulum is going to swing slower on the moon than what it does on the Earth. Now, let's go to the extreme. What would happen if you take your pendulum and you go deep, deep into outer space and you pull it out and you let it go? What do you think is going to happen? Make a prediction. If you're deep, deep, deep in outer space, what's the gravity like? It's going to be very small, if not zero. And so what would 0 divided by anything be? It would be 0. So you're going to take this pendulum and you're going to let it go, and it's just going to sit there. So there's no reason for this mass to want to move because there's no gravity out there. So that means that your pendulum would stay the same, and it's not going to do anything. All right, try this one. So now you've got two pendulums. You got a pendulum that has a length like this, and you got another pendulum that has a length like that. All right, you're going to pull them out and you're going to let them go. What's going to happen? Okay, this time, so let's do it for this one. This L is larger than this L. So what happens when you put a large L into the bottom part of a fraction? What comes out? A small number. So that means that if you lengthen the string, it's going to go back and forth slower. You could do this at home. So all you need is some string, put a weight on the end of it, and then watch it go back and forth, and then wrap some of the string around your hand so it's a smaller length, and then repeat the experiment, and then see what happens. Now, also, I want you to be able to do math questions with this. So you've already done it for the spring, so now let's do it for the pendulum. It says a pendulum swings back and forth with a frequency of 10 hertz. How long is the pendulum? So write down what you're given and what you're looking for. So we know the frequency, 10 hertz, and we're looking for the length. Okay, so we're going to select the formula that connects the letters. So that's going to be this one here. And so we know what the frequency is. That's the 10. Okay, it's going to be 1 divided by 2 times 3.14. And then the square root. Okay, now G is 9.8. That's the acceleration due to gravity. And then divided by L. Now the problem is that we need to solve it for the letter L. Now there's two ways of doing it. We could rearrange this formula for the letter L and then take the numbers and put it in and solve it. Or we could put the numbers in and then rearrange it for the letter L, and that's what I did. So either way is perfectly acceptable. So what I did was I put the numbers into the formula, and the first thing that I did was I calculated this part right here. So I know that this is 6.28, and then 1 divided by 6.28. Okay, so that's where I'm getting that 0.15 thing. And then the square root of 9.8 divided by L. Okay, the next thing I'm going to do is take this part over to this side. So I'm going to divide both sides of the equation by 0.15 something. Okay, then my next step is, what's the opposite of a square root? It's a square. So I need to square both sides. So now I've got 2.53 is equal to 9.8 divided by L. Now I still got to get the L over to the other side. And so that means I need to take the 2.53 over to this side. And so I end up with that result. And notice that I changed it back from meters, which really is the correct answer, but I changed it back to centimeters because that's something that you could probably measure with a ruler easier. So you did not need to take that final answer in meters and convert it back to centimeters, but I went ahead and did it. So those are examples of the types of questions that I would put on the exam that deals with these two formulas. All right, let's take a break. And when we come back, we will talk about the energy of a spring.